Hello guys, this lesson is about implicit differentiation and higher order derivative. So we start first with how we solve for higher order derivatives. Now what is meant by these higher order derivatives? So the higher order derivative is a derivative other than the first derivative and is used to model real life applications such as Euler-Bernoulli equation, which describes the relationship between a beam's deflection and the applied load, how fast curvature changes involving a fourth derivative. So it's written in this manner. So this actually means the fourth derivative of the function with respect to x. Now the fifth derivative's curve fitting to DNA is represented by this notation. Now, this version is used in structural modeling and shape analysis, that is DNA nanotechnology or polymer physics, where S is the length of the arc. Now, we have here some notations that we use to represent derivative of functions with respect to different variables. So you have here jerk or jolt, snap, and jounce, crackle, and pop. These are position vectors in physics. So look at this one here. So we have here, the first one is velocity, which is represented by the derivative of r with respect to t. And this is the notation used, this one here. But the derivative is dr dt, or the derivative of r with respect to t, and so on. That here for acceleration is the second derivative of r with respect to t, and jerk or jolt is the third derivative of r with respect to t, and so on. Now, to compute the higher order derivative, start from the original function. This is the rule. How do we solve for the derivative of, or the higher order derivative? Alright, so for higher order derivatives, these are the rules. First, so again, to compute the higher order derivatives, the first is to start from the original function and then apply derivative rules step by step. So like product, chain rule, quotient, and so on. And repeat the process n times depending on which one is asked. So here, we have here the notation for the first derivative, right? It's dy dx. How do we write the second derivative? You could write it as y double prime or the derivative of dy dx, this one here. We have the derivative of dy dx with respect to x. So, meaning, this one here is the first derivative with respect to, the first derivative of y with respect to x. If you're going to take the derivative of this again, that gives you the second derivative of y with respect to x. And the third derivative is denoted by this notation, and so on and so forth. Alright, so that in the notation, like, say we have y prime, then we also say f prime of x, or simply d sub x of y, or we could have, what else, f prime of x, besides this dy dx. But we have, besides dy dx, we also have y prime, f prime of x. So, instead of y prime, look at this one, you could write it as y double prime, y triple prime, but when it comes to the fourth derivative, you don't write it anymore in this manner. Y, diba? You have, instead of y 1, 2, 3, 4, you don't write it this way because there's a lot of primes here. So instead, we write it as to the fourth. So if say you have, so look at this one. Say we use f prime of x. So the second derivative is denoted by f double prime, f triple prime. Now, the next is represented in this manner. Alright? Then, yung next one is this one, and so on to the 6th, and so on. Alright? So these are the different notations we used in defining the second, the next higher order derivative. So look at these examples here. The question here is to find or determine the indicated derivative. So this means what? You'll be solving for the third derivative. So you solve first for the first derivative. So what's our first derivative here? Hold on. Let's use a different color. Which one is? Yeah, this one. Okay, so how will you solve for y prime? It's 5x to the 4th minus 20x cubed minus 21x squared minus 2. That's the first derivative. Now solve for the second derivative. So what you do is you differentiate the first derivative. So this gives you 20x cubed minus 60x squared minus 42x minus 0. That's your second derivative. For the third, you differentiate again the second derivative. So this gives you 60x squared minus 120x minus 42. So this is what is asked in the problem. Alright, so sometimes, or some students say that I will differentiate again. So once you get the first derivative, what they think is that if you solve for the second derivative, you are simplifying. You're not simplifying. When you differentiate a function again after getting the first derivative, you're solving for the next higher order derivative. Okay? So let's go over the next one. Now here what is asked is f double prime of 0. So how do you solve for? You solve first for the second derivative. This means the second derivative when x is equal to 0. So you solve first for the first derivative. So how will you solve for the first derivative? We have f prime, hold on. We have f prime of t. What will you use here? We use here derivative of product. This is the first term and this is the second term. So what we do is we copy the first, that's t squared minus 4. And then we multiply that by the derivative of the second. So that's 2 times t plus 3 to the 2 minus 1. We use chain rule. Then plus, copy the second term, that's t plus 3 squared times the derivative of t squared, which is 2t. Okay, then we simplify. Now in simplifying, we look for any common factor. So what's common? We have t plus 3. Now look. Kasi, you can also what? You can also, let's try simplifying first. Kasi you could also what? Simplify first before you get the second derivative. But let's try first factoring out the common factor. So what's common here? You have 2. And what else? T plus 3. So we have t plus 3 here. We also have here t plus 3. So we copy 2 and t plus 3 out. Alright? So then, what's left inside? So 2 and t plus 3 is out already. So you get here t squared minus 4 plus here 2 is out and one of the t plus 3. So what's left is t times t plus 3. Alright? So we factored out t plus 3 in the second term. So one of the t plus 3 is left and t is left. And then if we simplify further, we get 2 times 3 t plus 3. Then we simplify this term. So we have t squared minus 4 plus t squared plus 3t. Right? T squared minus 4, t squared plus 3t. So if we simplify further, we have 2 times t plus 3 times 2t squared plus 3t minus 4. So that's your first derivative. But what is asked is f double prime. So we continue by solving for the second derivative. Let's use a different color for the second derivative. So for the second derivative, we need to differentiate this one. Okay, so what is our second derivative? So we differentiate the first derivative. So for the first derivative, what formula will you use? To find the derivative of this one, what will you use? Derivative of product, right? But besides product, we also have here, which one? We also have constant. So bali, have a constant here times the product of t plus 3 and 2t squared plus 3t minus 4. So diba, if we have a constant, what we do is we copy the constant first. So we copy the constant first, and then we multiply that by the derivative of the next term. And in finding the derivative of the next term here, we use the derivative of what? Product. So we copy the first term. What's our first term? T plus 3. Then we multiply that by the derivative of 2t squared plus 3t minus 4. And that gives you 4t plus 3. 4t plus 3. Then, plus copy the second term. So 2t squared plus 3t minus 4 times the derivative of the first. Derivative of t plus 3 is 1. And then we simplify. So we have 2 times what? We multiply first this and this one. So we have 4t squared. Hold on. We'll have here 4t squared. And then we multiply this. It's 12t plus 3t. Again, 12 plus 3 is what? We get 15t. So 12 plus 3t is 15t. And then we multiply this too. So that is plus 9. Then, plus distribute the positive 2t squared plus 3t minus 4. Okay, and then, if we simplify further, we group similar terms. So 4t squared plus 2t squared is what? 6t squared. 15 plus 3 is 18t. 9 minus 4 is 5. So this is your second derivative. Alright? So if you want to find f double prime of 0, that's the one asked here. Then you substitute 0 for all the t that you see here. So this becomes 0, 0, so you have here 5, and the result is 10. Okay? Now, you may also do it this way. Instead of differentiating this one, this is another option. Diba? We get the derivative, which is what? Let's copy the first derivative. We know, okay, hold on. Let's just solve it here kasi it's too far. Here. Look at this one. This is another option. Or, we simplify f prime of t before finding the derivative. Diba dito? We find the derivative of this one. Hold on. We find the derivative of this function. Now, we can rewrite f prime of t by multiplying first t plus 3 and 2t squared plus 3t minus 4. So, how will you do that? We have 2, hold on. We have 2, we'll have here 2 times what? Multiply all the terms, hold on, let's remove this. Let's simplify by multiplying all these terms, or all the terms of the second, all the terms of the second term by t. So we get here what? 2t cubed plus 3t squared minus 4t. Then we distribute the 3. So we have what? Plus, what happened? 2t to the third, right? No, sorry. We are distributing 3. So 6, 6t squared. Hold on. 6t squared. We distribute 3. So 6t squared plus what? 9t minus 12. Alright? Again. 2t squared plus 6t squared minus 4t. Then 6t squared plus 9t minus 12. And then we group similar terms. So what happened? What is f prime of t? So we have 2 times what? 2t cubed, 3t square plus 6t square is what? 9t square. 9t minus 4t is minus 5t minus 12. Right? 3t square, 2t cubed plus 3, 9 minus 4 plus 9 plus 5t minus 12. Right? So, if you now solve for the second derivative, because this is your first derivative. So, how do you solve for the second derivative? We copy the constant times the derivative of the next term. So, we have what? 6t square plus 18t plus 5. Alright, so did you get the same answer? Yes, it's 2 times 6t square plus 18t, so you get the same answer here. So from here again, we can find f double prime of 0, and that gives you 2 times all this will be 0 times 5, you get 10. So you get the same answer. Now this red solution is shorter, diba? But you can do any of the two solutions will give you the same answer. Okay, let's go over the next one. This is exactly the same. T squared minus 4. Yeah, this is the same as this one. That's number 2 also. Okay, let's go to number 3. For number 3, what is asked is y double prime of negative 1. So what will you do here? First, again, we solve for y prime. So how will you solve for y prime here? We use here what? Derivative of product. So we copy the first, it's x squared. What's the derivative of e to the 2x? It's e to the 2x times 2. Plus copy the second term, which is e to the 2x, times the derivative of x squared, which is 2x. And then we simplify. So we get here 2x squared e to the 2x plus what? 2x e to the 2x. And here we could factor out which one? The common factor. And what's our common factor? It's 2x squared, right? 2x, sorry. 2x is common. And which one? And e to the 2x. Okay. Again, 2x is common. Same with e to the 2x. So, what's left here? If we this 2 is out already, e to the 2x is out, and one of this. So, what's left? X plus, here you have 2x e to the 2x is this one, so plus 1. So, this is your y prime. Okay? So, let's solve for y double prime. So, how do you solve for y double prime? What do? We can use again here, derivative of what? Product. So, this will be your first term. And this is the second term. So, what you do is we copy the first term. It's 2x e to the 2x times the derivative of x plus 1, which is 1. Plus, we copy x plus 1. And then we find the derivative of 2x e to the 2x. Now, remember, you get here what? The product of this and this one. So, to solve for its derivative, we have to use again derivative of product. So, we copy 2x, which is this one, times the derivative of e to the 2x, which is e to the 2x times 2. Plus, we copy e to the 2x times the derivative of 2x, which is, derivative of 2x, which is 2. So, again, what did we do? We use here derivative of product. This is your u and this is v. So we copy u, which is this one. Derivative of x plus 1 is this one. Then we copy the second term, which is x plus 1. And we multiply that by the derivative of the first, which is 2x times e to the 2x. But in solving for the derivative of this one, we consider this as u and this as v. So we copy u, derivative of v is e to the 2x times 2, plus copy v. times the derivative of 2x, which is 2. And then we simplify. So what's the resulting y double prime? 2x e to the 2x plus x plus 1 times here, again, we have here, what's common here? Kasi meron ulit common. Kasi we have 2, this one is common, right? So we copy 2 e to the 2x. Hold on, let's use here a bracket. Okay, so 2e to the 2x is common. So we factor out 2, sorry, this one, just this one. 2e to the 2x is out. So what's left inside? 2x. This one is out. So what's left inside? 1. Alright? So then, what's next? We have y double prime is 2x e to the 2x plus what? We check again if we have a common factor. Meron ulit. What's our common factor? Kasi this is actually, sorry. Because we have actually what? This actually, all multiplication, right? So, this is your first term, and this is the second term. So, again, we have a common factor, and what's common? You have 2x e to the 2x is common. 2, no, it's just 2. The only common is 2e to the 2x. 2e to the 2x, it's here. And it's also here. So, what's left in the first term? You have x plus, dito sa second term, we have x plus 1 times 2x plus 1. Alright? And then, if we simplify, can we simplify further? We get here, hold on. We get y double prime is x, 2 e to the 2x times what? X plus, if you expand this, this is 2x squared. 2 plus 1 is 3x plus 1. Again, 2x squared, 2x, 3x plus 1. And so if you simplify further, this is 2 e to the 2x times 2x squared plus, hold on, plus 4x plus 1. Okay? X squared, 3 plus 1. So, that's your y double prime. But what is asked is y double prime of negative 1. So, this gives you 2 e to the 2 times negative 1 times 2 times negative 1 square plus 4 times negative 1 plus 1. And so, if you simplify, this is 2 e to the negative 2 times this gives us 2, because this becomes positive, minus 4 plus 1. And so, that gives you 2, negative 4, so 2, this is what? Negative 4, negative 4 plus 3 is negative 1, right? Times e to the negative 2, which gives us negative 2 over e squared. So, we get the same answer as this one, negative 2 over e squared. And we get this as our first derivative, our second derivative, sorry. The second derivative is this one, right? Which is this one here. Okay? Now, we use here which one? We use the same step as what we did here. We use here what? Derivative of the product. We started by, for this solution here, we started by getting the derivative of this one. And we use product. Yung susunod na, the other option is to distribute or to simplify first by distributing and then finding the second derivative. So we could also do that here. Look, with this function, with this given function here, this one. What's our other option? We're given y prime is 2x e to the 2x times x plus 1. Now look, if you distribute, you can write this as what? Distribute this one. So that gives you 2x squared e to the 2x, right? 2x squared e to the 2x plus 2x e to the 2x. Okay? So in that case, how do we solve for the second derivative? Let's just write it here. Tatamaan tong kabila. Alright, so let's just continue the solution here. So how do we solve for the second derivative? But here, look, you'll use here what? Product. Okay. Yes. You'll use here derivative of product. So what do? We copy the first, it's 2x squared. Derivative of e to the 2x is e to the 2x times 2. Plus, we copy what? E to the 2x times 4x. Okay, plus, there's a lot. So, what's the next one? We have 2x. Because again, you have here product, alright? So, we copy 2x. Derivative of e to the 2x is e to the 2x times 2. Plus, we copy e to the 2x times the derivative of 2x, which is 2. Alright, and then, we get y double prime is, this gives you what? 2. So, 4x squared e to the 2x plus 4x e to the 2x plus this gives you 2 times 2 is 4x e to the 2x plus 2 e to the 2x. And if you simplify, we get y double prime is how many? E to the 2x. So look, you have 4x squared plus 4x 8x. Okay. 4x squared, 4x plus 4x is 8x. Let's check if we're going to get the same answer. All of them have what? E to the 2x. So we have 4x squared. Hold on. We'll have 4x squared. 4x plus 4x is 8x. Plus 2e to the 2x. Plus 2. And then we multiply by e to the 2x. So that's your second derivative. So did we get the same answer as the first method here? Yeah. You get 2e to the 2x. Because here, because this is what we get here. Pero dito kasi we can write this as what? We can factor out 2. So you'll have 2x squared plus 4x plus 1 e to the 2x. So it's the same as this one. You have, this is 2 e to the 2x times what? 2x squared plus 4x plus 1. Alright, so any solution using the first or the second solution, you get the same answer. So when you get this one, right? Pareha lang. So when you substitute y double prime of negative 1, you should get what? Negative 2 over e squared. Alright? Okay, next. Determine again the indicated derivative. So, we are asked here to solve for what? The second derivative. Alright, so let's solve first for the first derivative. So, what's the first derivative of this one? You have to use here derivative of what? K times what? Hold on. Derivative of, again, what formula do we use here? The derivative of K over f of x. So, how do we find the derivative? Or, you could also write k over v. Ano ginagawa natin dito? That's negative k times what? The derivative of v over v squared. So, but you can also use here quotient. If you don't remember this one, we can still use the derivative of quotient, which is u over v. Diba? If you use u over v, it's up to you. You can use the first formula or you can use the second formula, which is u over v. But for this one, you have v du minus u dv over v squared. So, in here, if you use this second formula here, in this problem here, this is u and this is v. So, how do we solve for the derivative? We copy which one? V. Use this one here. Copy v. What is v? X squared minus 6x. Derivative of 2 is 0. Then minus copy 2. Derivative of x squared minus 6x is 2x minus 6. Over x squared minus 6x is square. Right? So again, we use this one. U over v. So v du, v is x squared minus 6x. Derivative of 2 is 0. Minus 2 times the derivative of x squared minus 6x, which is 2x minus 6, divided by v squared. So, therefore, this one, when you multiply this is already what? 0. So, what's left in the numerator? You have, here we could factor out 2. So, 2 times 2 is negative 4. Then you have x minus 3. Then, in the denominator, you have x, factor out x, and you get there what? X times x minus 6, right? We factor out here x. So, you have x times x minus 6. But this must be what? Squared. So, our first derivative, our first derivative, when simplified, is equal to negative 4 times x minus 3 over x squared times x minus 6 is squared. So, this is your first derivative. This is your f prime of x. Okay, this one. Now, if you're going to analyze, you still have to solve for the second derivative. So, you have to differentiate this one. But look, which one is easier to differentiate? Because this is also your f prime of x. Hold on. This is also f prime of x. Kasi you need to differentiate the first derivative again. So, if you're going to use this one, this is more this form here is hard to differentiate rather than simplifying this. Okay, kasi you can proceed to this first, to this step. F prime of x is negative 4 times x minus 3 over x squared minus 6x squared. I think it's for me, it's easier to differentiate this one rather than this one. Because for this one, you'll be using quotient and then in the denominator, you have to use product. But if it is of this form, you also have to use quotient. But in finding the derivative of x squared minus 6x, you just have to use here u to the n. Alright, so let's proceed to finding the second derivative. Let's find the second derivative using this one. Okay, so let's proceed here. Okay, so what's our second derivative now? We have this one is your what? Okay, hold on. We could actually write this first as the negative of 4 times this one. Diba? So, in finding the derivative, we have to copy the constant first. And then we multiply that. Hold on. Tama pala siya dito. Okay, I think we just have to continue sa baba. Not here. Okay. So, let's continue with this one here. So, we solve for the second derivative. And so, what do? We copy the constant first. We have a constant here, right? So, we copy the constant first. Negative 4. And then, how do you solve for the derivative of the next term? This time, we use again what? This is u, and this is v. So, how we solve for the derivative? We'll have what? Use derivative of quotient. So, we copy v, which is 6x, x squared minus 6x squared, times the derivative of the numerator, which is 1, minus, copy the numerator, derivative of the denominator. You use here u to the n. So, 2 times x squared minus 6x to the 2 minus 1, which is 1, times the derivative of x squared minus 6x, which is 2x minus 6. 2x minus 6. Then we divide it by x squared minus 6x squared. So, if we continue, we get what? Negative 4 times. Now, look. You have a common factor here. Because you have here x squared minus 6x. And you also have here x squared minus 6x. So, we can factor out first which one? We can first factor out x squared minus 6x. What else is common? Yun lang. Because this is simply x squared minus 6x. Itong first term. So, one of this is out already. But one is left. Alright? Then minus what? This is already out. So, you have 2 times x minus 3 times what? 2 times x minus 3. And here you could factor out 2. So, we'll have x minus 3 also. Right? But guys, look, instead of factoring, kasi we need to simplify this one, we have to combine similar terms. So, we don't factor out 2 anymore. Instead, we multiply. So, what's left here again is 2 times x minus 3 times what? 2x minus 6. Alright, so, f double prime of x, therefore, is negative 4 times x squared minus 6x times x squared minus 6x. Now, we multiply this 2 here. And times 2. So, we have 2 times what? 2x squared. So, we have 2x squared. Then, here we have minus 6, right? Minus 6x minus 6x. So, we have negative 12x plus 18. It's 3 times negative 6. And so, if we distribute the 2, we have negative 4 times x squared minus 6x times x squared minus 6x. Distribute the negative 2. So, negative 4x squared plus 24x minus 36. Correct? So, we simplify further. We have what? Negative 4 times x squared minus 6x times. Again, let's recheck this one. Minus 4 plus 24 minus 36. Alright, then we group similar terms. X minus 4 minus 3x squared. Minus 6 plus 24 is plus what? 24. Hold on. Positive 24 minus 6. We get what? 18. X. Hold on. 18x minus 36. Alright? So, x, okay. So, that's your second derivative. But the question is, for us to solve for, yeah, wala na. It's the only question, sorry. So, this is the final answer. Alright? So, it's easier to differentiate this. It's easier to use this option here rather than this one. Okay? So, it's the same question. Pareho to this active number 3. Okay. Oh, number 3 is repeated again. Now, what happened? There is a difference here. Hold on. Ah, yeah, we forgot the denominator. Hold on. So, this is just simply what? Kasi the solution is too long. Kasi we forgot the denominator. What is our denominator here? So, dito na lang natin, just write the denominator here. This is the final, sorry. This is the final answer. But we have to have here our denominator. And the denominator is what? X squared minus 6x squared. So that's your f double prime of x. And then you can see that here, we can cancel this out. So the numerator now is negative 4 times what? Negative 3x squared plus 18x minus 36 over what? X squared minus 6x. Alright? So, is it the same? What's our answer here? Yeah. So, how did it become 12? Because we factor out, kasi here, pareho naman sila, but you can continue simplifying this by factoring out which one? Negative 3. So, if you factor out negative 3 here, this becomes 12 times what? X squared plus 6x minus 12 over x squared minus 6x. So, we get the same answer. This one. Why is it cubed? May mali pa ulit tayo. Hold on. Ah, yeah, because it's already x squared. So, there's something wrong again. Sorry for that. This must be what? Raised to the 4th. Okay, so, we should divide this by raised to the 4th. Okay, so if we cancel one of them, this is now raised to the 3rd. Okay. So, it's the same as this one. Right. Now, these are some questions for you to practice at home. Alright? Now, the next is implicit differentiation. So, what is meant by this implicit differentiation? Now, take note that functions are defined either implicitly or explicitly. So, functions can be defined implicitly in terms of x or explicitly in terms of x. Now, these are examples, some examples of explicit form and implicit forms. So, for the function y equals x to the 4th minus 6x squared minus 3x plus 5, your y is defined in terms of x only. Here, you can see only which one. On this side, you can see only the x variable. Same thing on this one. In here, you just see only t, right? But in here, on the right side, okay, this one here. Let's go over number 2. On the right side, for this one, you have x and y, both present on two sides of the equation. Same thing with this one. On the left side, you have x squared plus minus xy plus y squared. You don't expand, or you did not express y in terms of x. Right? So, these are examples of implicitly defined functions. This one here. These are implicitly defined functions, but these are explicitly defined functions. Again, when you say explicit, you can express y in terms of x on the right side, or in terms of a single variable on the right side. But if it is implicitly defined, it's like x and y are combined together. You cannot solve for y in terms of x alone. Okay? So look, how do we apply implicit differentiation? It says here that differentiate its term with respect to the independent variable. Gather all the terms with the dy dx on the left side and solve for dy dx. So, x squared minus y squared is equal to 4. Okay, so let's solve this one here. Let's solve it this way. We may disregard this first kasi here I told you you don't write these steps anymore, diba? Ito mga steps na to. Alright, so let's solve it using using another option. So we are given x squared minus y squared is equal to 4. What is asked is to solve for dy dx. But this equation is defined implicitly. So how do we solve for dy dx? What's the first step? Differentiate its term with respect to the independent variable x. So what's the derivative of x with respect to x? That's 2x. But the derivative of y squared with respect to y is 2y y prime. And the derivative of 4 is 0. Okay. So, diba, if we are given x cubed, its derivative with respect to x is 3x squared. That's the derivative with respect to x, right? But if we're given y cubed, the derivative of... Hold on. Sorry. What happened? Okay, so for this one, we say that the derivative of x cubed with respect to x is equal to 3x squared. But if we're given y cubed, the derivative of y cubed with respect to x is what? 3y squared. Remember, this is not x but it is y. Right? So, 3y squared times y prime, or times what? dy dx. Dito kasi, 3x squared times the derivative of x, which is 1. But here, 3y squared times the derivative of y, which is y prime. Ulit. Let's rewrite it. Okay, so, if we're given y x cubed, we know that to find its derivative with respect to x, we write it as 3x squared times the derivative of x, which is 1. That's why we get 3x squared. But if we're given y cubed, alright, and we want to find the derivative of y cubed with respect to x, that's 3y squared times the derivative of y. It's not x. So, you should write it as dy dx or y prime. Okay? So, for this one, to find the derivative of x squared, it's equal to 2x. Derivative of y squared is 2y times the derivative of y, which is y prime. And the derivative of 4 is 0. Then, we solve for y prime. So, we transpose, but before we transpose 2x on the right side. So, we have negative 2y y prime is negative 2x. How do we solve for y prime? We divide minus 2x by minus 2y. And that gives you x over y. So, which means that our y prime is x over y. Right? So, you get the same answer here. So, you don't just look at this solution. Okay? Ito na lang. Just look at this one. This is simpler. Alright. Let's go over this one. So again, we're asked to find dy dx. This is the given function. So again, this is implicitly defined. So we differentiate each term of both sides of the equation. So what's the derivative of x squared? That's 2x. Now, how will you find the derivative of this one? You have to use product. So this is your u and this is v. So to find the derivative, let's use here a parenthesis. We copy u, which is x. Derivative of y is y prime. Plus we copy y, that's your v. Derivative of u, which is the derivative of x is 1. Okay, then plus derivative of y squared, which is 2y times y prime. And on the right side, you have 0. Then we simplify. Distribute the negative. So minus xy prime minus y plus 2y y prime equals 0. Now we need to solve for y prime. So we group all the terms with the y prime on the left side. So what are those terms with the y prime? Minus xy prime plus 2y y prime. Then we move 2x on the right side. 2x negative plus y. We factor out here y prime. So what's left? Minus x plus 2y. And then we have here minus 2x plus y. So we get y prime. We divide now minus 2x plus y by minus x plus 2y. Right? It's the same as this one. Kasi you could write this as, pwede itong y minus 2x and 2y minus x. This is OR. Alright. Next, we go to this one. Okay, this is what is asked. So which means that you'll solve for the first derivative muna first, and then substitute 1 for x and negative 1 for y. Okay. So how do we solve for the derivative? This is implicitly defined. So we differentiate all the terms. Differentiate this one, this one, this one, and this one. So what's the derivative of x? It's 1. But for this one, okay guys, before we differentiate, you simplify this first. So wag muna tayo mag-differentiate. Because you could write, so simplify the equation first. What's our objective here? To simplify differentiation. To make differentiation easier. So, we have x plus ln of product can be written as what? Ln of product can be written as the sum. So, ln of x plus ln of y is equal to xy plus y. So, this is now this is now the function. This is now the simplified function. We did not differentiate yet. So this time we find the derivative. So find the derivative. Okay. So what's the derivative of x? It's 1. Okay, derivative of ln of x, 1 over x times 1. Derivative of ln of y is 1 over y times y prime. And that's equal to what? Here again we use derivative of product. So we copy the first, it's x. Derivative of y is y prime. Plus copy the second, which is y. Derivative of x is 1. Plus the derivative of y, which is y prime. So if we simplify, the right side is 1 plus 1 over x. Plus 1 over y prime. And then we have the x y prime plus y prime. So we group all the terms with the y prime on the left side. So we have what? 1 over y prime minus xy prime minus y prime equals all the terms without the y prime on the right side. So we'll have what? What's left here is y, then minus x minus 1 over x. Alright, so then we factor out y prime. So we get here 1 over y minus x minus 1. 1 over y minus x minus 1 is equal to y minus x minus 1 over x. So, if we solve for y prime, that will give you y, hold on, there's something wrong. We have y, hold on, y minus, okay, the right side is, this should be what? Again, we have something wrong with this one. We have minus, hold on, it should be, what should be on the right side? The one with the blue. So minus, sorry, y muna. Let's have first y. So it's y minus 1 over x minus 1. 1 over x minus 1. Alright, so this is y minus 1 over x minus 1. Y minus 1 over x minus 1. Over 1 over y minus x minus 1. So this is your y prime. But what is asked is this one. So what will you do? How do you solve for f? F of negative 1, 1. So replace y by what? Replace, kasi this is your y. Replace y by, this is your x, and this is y. So replace y by negative 1 minus 1 over 1 for x minus 1 over 1 over negative 1 minus 1 minus 1. So this gives you what? Negative 3, right? Negative 3 over negative 3, which is what? Positive 1. So that's how you get this answer. Okay? Questions? Sorry. Okay, so that ends this lesson. You can do this number, and this is the solution. I mean, the final answer. So try number 4 at home, and try these exercises also. Oh, there's a solution for the last, I think this is the first number. Yeah, there's a solution for this one. And it's here. Now, all the rest do not have solutions. Do that on your own as your practice. Alright? So, that ends this lesson. Bye-bye.